The future is here. We're building robots today. Awesome. Really awesome. So we have Robert here to take us through on how it's all done. So he's from MakeSpace in Cambridge. He's come specially from the UK to join us today. And I'm very excited to build my first combat robot. So please show me how it's done. Thank you. Please, Robert.
Hello. Right, so the talk's titled Building Your First Combat Robot, but it's a bit more about designing your first combat robot. So I've been interested in Robot Wars and the like since about 1998 when it first came out on BBC TV. So this is back in the day. First robots. It's quite fun watching them beat the crap out of each other. So that's my Twitter and my website. So this covers my experiences when I've kind of started building a robot properly. So, I mean, I've been interested in since 1998. I kind of tried to run a robot club at secondary school. So teenage years on building little combat robots that never quite worked. So this talk is covering kind of what I've seen, what I've observed, what I've kind of, my mental model of how it works and what you want to do in order to build a robot that will be effective and not suck. So when you're building your robots, the first thing to do is decide what weight category you're going into. The two big popular ones at the moment are the heavyweights, which are 100 kilos. These are the big heavy robots. They're the ones that you would see on, say, BattleBots, the American TV series that just restarted up last month and did 6 episodes. And they cost maybe £2,000, what's that? Several thousand euros, dollars, what have you. So they're big, they're expensive, and because they're big, you can put an awful lot of high-powered weaponry on there, and they generally don't, they can do a lot of damage to themselves and others. Not something to get started in. Featherweight combat robots, on the other hand, they're about 13.5 kilos, or 30 pounds if you're American. And they're a lot cheaper. They're more in the kind of the 800 mark. So you can feasibly build 1 or 2 of these robots, and they're smaller, but you can still pack quite a bit of heavy, high-powered weaponry in them. So it's a bit more friendly for learning the ropes and kind of figuring out what works, what you prefer weapons-wise. I go too fast. Right, so I mentioned the money in relation to how much a weight class is. Its weight is your currency. You can always find more money to spend on it, but you are limited by how many kilos you can spend on it. And you've got to spend it on your chassis, so the kind of the skeleton of your robot. You've got to spend it on the armor, the skin, to protect your robot. You've got to spend it on the wheels and the motors to make it move, the motion generating stuff. And of course, the most important, you have to spend it on the weapon. And you can't spend too much on the weapon because then you're very slow and you don't have much armor and you're quite weak. But you can't spend it all on motion because then you don't have much armor and don't have much weapon. And so you have to find the right balance that works for you. So the chassis. So the chassis of the robot is pretty much what everything bolts into. Like I said, it's a bit of a skeleton. One thing to keep in mind is, because everything's bolted to it, everything will translate through it. So every time someone drives into you, the shock of that will translate through your chassis. So you want to make it light and rigid, so it doesn't flex too much and it doesn't kind of break apart. And I mean, some of the BattleBots robots tried to go with a slightly lighter and a bit more flexible chassis, and that didn't work out too well for them. Generally, you find rigid chassis work well, flexible ones not so much. So the other thing is, there are some weapons out there that will launch you up into the air. So when you come back down again, thanks to gravity, you're going to get forces from slightly weird angles from that. So you need to also be able to resist them, or at least deal with them. You can cheat slightly. So what you can do is you can say, I'm actually going to make my armor the chassis, and then you bolt everything into the armor. You end up putting a bit more weight into the armor to do that, to kind of put mounting points in. And it means that if your armor sustains a big hit and gets bent out of shape, your chassis then ends up having to be bent out of shape, which could be bad. Say, makes one of your wheels lift off the ground, so now you've lost your motion, which sucks. So there are advantages, there are disadvantages to cheating and making it your armor. So this is the robot I'm building. It's a featherweight, and this is its chassis. It's about 400 millimeters by 450 millimeters. So it's what, 450 vertically, 400 horizontally. It's using drill motors for the motion and the weapon. I think I've over-engineered this chassis quite a bit. It's far too rigid and far too strong and not light enough. The silver bits are aluminium C-section in 1/8 inch or 3.125 mil thick, and then it's got blanking plates welded on the ends of them to keep them solid, and then I've drilled and tapped them. So it breaks down quite nicely, but I think it's far too strong, which means I've had to lose out on other parts. So the other one is armor. So you can't dodge all of the attacks that your opponents will throw at you. You can dodge some of them by being fast and nippy and practicing your driving, but there will be a point where you accidentally end up in a corner and they'll ram into you, or they'll get a lucky hit on you. So for featherweight robots, most armor in the UK seems to be a type of steel called wear plate, or so these are steels that have been specifically heat treated and are made up of special alloys. And they look a little, and they've got similar kind of properties to, say, titanium, but they don't cost anywhere near as much. It's also quite easy to work them. Titanium likes welding itself to drill bits quite easily, and that ruins the drill bit and the titanium. Titanium's expensive, so it gets painful. With steel wear plate, it's basically just steel. Another cheaper alternative often used for first-time robots is thick plastic. So chopping boards are made out of plastic called HDPE, and you can buy that in quite thick sheets, maybe 20 mils thick. What's that? It's just under an inch. So you buy that and you can basically cut it up. It's quite easy to work with because it's plastic, so you can cut it up and you can build armor out of it. And because it's very cheap, you can build lots of bits of armor for it, so you can swap them out as they get damaged. And that works out quite well. One thing to do when you're building your armor is you've got to think a bit about the geometries of it, the shape. For some weapons, for say spinners, they have bars that spin around, and if you have sharp corners, the bar will hit that sharp corner and it'll catch, it'll grip on, and it will then rip your armor off, which is bad. So you want to try and have everything sloped in slightly, just so it's more likely that glancing blows will then bounce off and redirect the force rather than just trying to resist it. So I've then gone and broken all these. So I've got straight sides on mine. I'm using steel wear plate. So I've got sharp corners and I've got straight sides, the two things I said not to do. So I'm a terrible person. It'll be interesting. So mine's wrapped up in 4mm Hardox, which is a steel wear plate. That's around the outside. The orange thing in the middle is the lifter arm. That's made out of 3.8mm wear plate. That's been made up and welded. And then the top and bottom armor for me is 5mm polycarbonate. I just wanted to see I wanted to be able to see the insides of the robots. If I was slightly more paranoid, say for overhead axe weapons, you'd probably want to move on to more, again, steel wear plate or thick plastic, thicker polycarbonate. I mean, polycarbonate's quite a nice plastic, but it's a bit pricey, and it's HDP is a bit more easy to work with. So motion's quite important. Basically, as I've got, it lets you control the arena. It lets you be everywhere where your opponent's weapon is not. So you can line up and you get yourself into a position where your weapon can attack his sides and his rear, and he can't attack you. And you can get away from him trying to attack you. You can try and get him into a corner so he can't maneuver much. So that's what you want to do. I mean, I see a lot. I mean, a lot of these fights end up on YouTube, and you can watch through them and say it's research, or just enjoy the fact that robots are getting destroyed. And one thing that I see coming up quite often is a lot of people don't do too much practice with their robot, so they're not too good at kind of controlling it around the arena. And it's not easy, especially when it's driving towards you, because you've then got to flip the left-right. So you have to move the stick right, and then it steers left. That kind of messes with your brain a bit. But if you do a fair bit of practice with it, you should be able to kind of get it so you can actually get it doing what you want it to do, nice and quickly. The other thing I see quite a bit of on the YouTube things is people just basically going straight from standing still to full speed. That's not really controlled. That's just kind of bumping off everything. You want to avoid that. You want to try and kind of be the right speed for the position. So go slow to try and accurately position yourself correctly. You want to keep an eye on the steering. Slow down before you hit stuff. Driving full speed into the arena sidewalls is just as bad as your opponent driving full speed into you. It's not something you want to kind of happen if you can help it. So for featherweights, common things to move your robot around are cordless drills. The price for those has come down greatly in recent years. So you get an 18-volt cordless drill, you rip off all the plastic, you mod the clutch, it's got a little torque control clutch to stop it from stripping the gearbox. Great for drills, terrible for robots. So you jam that somehow, and that gets you a fairly cheap, powerful drive motor. And then to control the motor, you generally used cheap Chinese brushless motor controllers that have been they have the firmware hacked and modified, and you just program them up, and it then looks like a brushed motor controller. The Chinese RC kind of market has been great for combat robotics because it's just dropped the price out for a lot of the internal electronics. You can now buy very cheap brushless motors, which are great for spinning weapons. You can buy cheap speed controllers, which for both brushed and brushless. And you can get cheap RC equipment, so the remote controls that let you control the robot. That's dropped in price massively, and also gone up in functionality as well. You can get some really amazing control setups that's come out of drones and the rest of it. So that's my setup. You can see the aluminium C-section there at the bottom. So I've got two 73mm diameter wheels. I've got a belt drive linking the two, and then the motor and the speed controller are mounted at the back. And then the speed controller's on a bit of isolation to try not to translate shock through to it. It goes quite fast. I haven't done the maths and figured out exactly how fast my one travels, but I generally joke that it goes faster than you can run. So keep your eye on it, watch your ankles. So another big one is the weapon. So you've got an idea now of like the chassis shape you want to have, the armor, and the wheels. Next, the most important fun one is the weapon. So there's lots of different weapon types out there that you've got. The two The two that I like, I think are the most effective and or destructive, are flippers and spinners. Spinners, I mean, there's other ones out there. You've got the piercing weapons, which basically put holes in the other guy. And you've got flails, which are just things on chains or rope that you kind of whip into them. They look nice, but they don't really cause much game-ending damage. Yeah, spinners can do some amazing amount of damage. So I don't know if anyone's watched BattleBots in the US, but there's something called Last Rites, which has this big metal bar that it spins around maybe 5 centimeters off the ground, and then that wangs into the other robots, and it was very effective, and it ripped a couple of robots completely to bits. There's also Ice Wave, that was the other one that had a horizontal spinner. In addition to the horizontal spinners, you also get vertical spinners, so you get drums. So they'll have a drum with teeth on it, and then that'll spin. Spinners are very effective, but they have this downside of because there's a lot of kinetic, rotational momentum energy. If they can actually damage themselves as well, they can do just as much damage to themselves as they can an opponent. Just because if they hit them right, then they can fall on, and the weapon will hit the ground, and the shock will translate into the chassis and kind of shake it to pieces. And it's rare for spinners to. I mean, see, everyone likes spinners because they do they can destroy an opponent, but that doesn't happen too often. Most of the time, you'd end up just knocking stuff around. Flippers, on the other hand, are a lot more singularly effective because you can flip someone entirely out of the arena, which is an instant win. You don't have to chase them round for the rest of the match and then win to a judge's decision. You just flip them straight out, and that's it, won. So yeah, no, those are my two favoured. Don't think that you can put two weapons on. That never works out well. You need a certain amount of weight given over to securing the weapon in place. So if you've got two weapons, you have to have twice that weight, and that subtracts. So much better just have one big, powerful weapon. Of course, again, as with turning your armor into the chassis, you can cheat, and you can make the robot the weapon. So you can build what's called a rambot. So you just build this brick that's got nice, strong, rigid chassis and armor, and then you drive it into everyone else at high speed. 13 kilos running around at 20 miles an hour is quite a lot of force, quite a lot of momentum, and that can do quite a bit of damage. Yeah, so this is my robot, and that's a bit of railway rail. So you have to have lights on it to show that it's working, and so I've just got a lifter. It's a bit like a flipper, but it's a lot easier to make. I'm using a linear actuator, which is basically a drill driving a threaded rod and a trap nut. So it just extends and shortens. It's easy to make. It's less likely to hurt me. Pneumatics, which is normally what's used for flippers, is quite dangerous to play with unless you know exactly what you're doing with. But yeah. So I'm just talking about balance. There is no perfect kind of balance set up yet. Every robot has a slightly different kind of ratio of how everything goes together. And what works really well in one season of in one set of robot fights won't necessarily work so well the next time round. Because people keep perfecting and updating their designs. So it's good because it means you have to constantly evolve your robots, which is great fun, because you're constantly trying to pick yourself against other people. So yeah, that's pretty much it. these are the resources I use. So fightingrobots.co.uk is a big UK website where a lot of people talk about combat robots. Spark.tools, which is probably the best URL I've seen to date, is an predominantly American website. It's trying to cover a lot of the smaller scales, smaller weight classes. Robot Wars is the Australian forums. They've very much gone into, the Australians really have gone into robot combat in a big way, and it's where the hacked brushless motors came out of. Brushless motor speed controllers. E to the I pi plus 1 is an American guy called Charles Guan from MIT who posts very good informative blogs about building robots and silly vehicles. He was on the latest version of BattleBots with Team JCAB, which has got Overdrive, which is a very nice robot. It was quite nice. Didn't do too well, though. So yeah, thanks for listening, and any questions?
Please take a seat for questions or to the microphones.
Jesus Christ.
So we have microphones set up on the left and right. Please head to a microphone if you'd like to ask some dangerous design questions. Please.
In the original UK Robot Wars, it tended to be, as the competition went on, it became less accessible to people with less money. So people with more money tended to win all the fights at the end. Do you think there's any way you can keep these accessible to newbies, people without much money?
Not sure, really.
Yeah.
I mean, so you can do stuff like, so in America they've got the sportsman subclass. So it's the £30 combat robots, but then they have weapon limits, which then means you can enter with a slightly less armored, less fancy robot and still win. I mean, it's the weapons. If you've got more money, you can spend on fancier armors and more powerful weapons. So if you limit them weapons, then that kind of sets a maximum on the cost there, and then it means you don't have to spend too much on your armor, and you end up getting slightly more interesting robot designs than, say, just spinning a metal bar at several thousand RPM and driving into your opponent as fast as possible.
Okay. Thank you.
Just technical details. The arm is not electrically moved, which is compressed air or things like that. The arm.
So how does the arm move?
Uh-huh.
So it's on a 4-bar linkage. So the linear actuator is just a motor that goes through sponge gearbox, turns a threaded rod, and then there's a trapped nut that can't rotate, so it just moves back and forth. And that drives a piston, basically, that moves the linkages, which gets the arm to move up and down.
Could you perhaps, Robert, tell us a little bit about some of the other things you're doing while you're here at the camp?
Say again, sorry?
Could you perhaps tell us a few things about what else you're doing while you're at the camp? Will you be around to field questions, for instance?
I'll be around for questions afterwards, sure.
And where can people find you if they're looking to discuss?
I'm living out of the EMF camp over up towards the extra shortest path.
Because there is their own little CC camp robot war going on here today or tomorrow.
So there's the HeboCon competition, I believe, which is the Japanese shitty robot competition where you try and build robots that aren't so great and fight them. I believe that's happening today, and there's a contest tomorrow for that. Yeah.
So we can try our silly robots before we get excited with the combats. Are there any more questions? Design questions, theory questions. Is that one coming up now? Got a really small person about to ask you. No? Okay. No. Not yet into combat. Okay. Thank you very much. Please, a warm applause. That was fantastic.